I'm going to go ahead and take a look at converting from a decimal system or a base 10 number like 97 and 341, convert that into a base 5 number, and then we'll take a look at some non-base 5 bases and look to see what that could mean. So let's take a look at this question here. 97 is the same as 342 in base 5. Again, that's 9 10s and 7 1s. How do we convert into a base 5? Well, we have to first understand the place value. Each location means something. And so for 97, I just looked at the place value and said, okay, look at the biggest one that goes into 97. And I say, okay, 25 does. How many times does 25 go into 97? 3 times. And that's 75. What's left over is 22, right? 97 minus 22. So that's kind of the calculation that's going on in my head after we had that. You have 97 minus 75 is 22. And then you say, what number, how many times does 5 go into 22? It goes 4 times. That's 20. What's left over is 2. And so that's where you get the numbers 3, 4, 2. 3 25s, 4 5s, and 2 1s. Now 341 is a little bit harder because the number is bigger, but we go through that same process. How many 125s, how many times is 125 going to 341? 341, 2 times. Okay, and so that's where you have 2 in the place value here. What's left over after 341 minus 250? 250 again is 125 twice. What you're left is 91. How many times does 25 go into 91? 3 times, and that's 75. So what you're left over, what's left over is 16. And then how many 5s go into 16? 3 do. So that's 15. Remainder 1. 1 left over. And so that's where those numbers come from. I'm not going to explain fully the algorithm. I kind of like, just for our purposes, we'll keep the number small, but there is an algorithm you can use. It's in the book and it's also here. You might want to pause and read it about how to convert. It's the same way that that kind of my thought process that we went through. You do a long division. You start with the biggest number. How many times does 125 go into 341? 2 times. The remainder. How many times does 25 go into 91? And then as you do it, you'll see you end up with your base 5 number across there as you do that. So again, there's an algorithm you could use, or again, a process you can use to solve, to convert those numbers. And then the last examples here, look at other bases. And so what is 1 0, 1 1 0, 1 1 2, base 2? What is that? Well, now that means our powers are 2. So you can see 1, 2, 4, 8. Those are the place values. What is a base 8 system? 1, 8, 64. Again, this is just to give you a sense of what young children learn when they first learn base of 10. These numbers are new to you and they're kind of foreign. And it's like, I don't really understand these different bases. Well, young children have the same issue, base 10. Why did we choose base 10? How come we're not using base 2 or base 8 or base 12? And in base 12, we run out of digits, right? Because base 12 means we're going to have 12 digits, 0, 1 through 0, 1, 2, 3. And then we need single digits. And so we use T and E to represent 10 and 11. T represents 10, E represents 11. So what is this number here? You can see what happens here. We have place values. This means one group of 144, 10 groups of 12, 11 groups of 12. So you can see that's really an 11, and then this is a 10. So you can see where those numbers come from. And in base 2, again, you can see our place values in its expanded form. One group of 16, one group of 8, 0 groups of 4, one group of 2, one group of 1. And then base 8, you can see our place values. Again, the key thing to understand is that each of these digits represents a value, amount of that place value. And so keep that in mind. Again, you'll practice that on homework. And then the last thing is example 216 here, 53 in base 2. How do we do that? Again, here's kind of an algorithm, but you go through that process in base 2, thinking about what are my place values, right? The place values I have are 32, 16, 8, 4. Those are powers of 2 and 1. And so you ask yourself that question of how many 32s go into 53? And I know that answer is 1, and that's where you can see this long division. What's left over is 21. Then you say, how many 16s go into 21? 1 do. What's left over? 5. How many 8s go into 5? 0. How many 4s go into 5? 1. What's left over? 1. How many 1s go in? Sorry, how many 2s go into 1? 0. And then how many 1s go into 1? And so you can see that answer there. So that's looking at other bases other than base 10 and base 5.